In the last video, we talked about how to find the weighted average given all the values and their weights. Your reputation as a realtor is growing, and you have your goals set on selling properties at an average price of $2,630,353.80 so you can bring home more money. Now, instead of calculating the weighted average, you have to determine the percentage or weight of each type of property you have to sell to achieve your financial goal. So, how can we calculate missing weights given the weighted average? The most important thing to remember is that the weights will always add up to 1 when written as decimals and 100% when written as percentages. Let's start by setting up our weighted average equation. From our last video, a townhouse costs $910,000, an apartment costs $2,000, and a mansion costs $6 million. We also know that our desired weighted average is $2,630,353.80. Thus, we have $2,630,353.80 equals F1 times $900,000 plus F2 times $2,000 plus F3 times $6 million. Remember, F1, F2, and F3 represent the weights in a general weighted average equation. Let's start with a problem where we have to solve for one unknown weight. 2,630,353.8 equals x times 910,000 plus 0.1049 times 2,000 plus 0.3567 times 6 million. What percentage of the properties we sell need to be townhouses to meet our goal? Taking into account that the weights in the weighted average equation add up to 1, we know that x plus 0.1049 plus 0.3567 equals 1. How can you rearrange this equation x plus 0.1049 plus 0.3567 equals 1 to solve for x? We can rearrange this to be x equals 1 minus 0.1049 minus 0.3567. This results in x equals 0.5384. So, this means that of the total number of properties sold, 53.84% need to be townhouses, 10.49% apartments, and 35.67% mansions to achieve our goal of our average price of $2,630,353.80. Let's try another example with the following equation. 0.21 times 46 plus x times 49 plus 0.36 times 42 equals 45.85. Solve for x. Start by writing x in terms of the other weights. The answer is B. Remember that the weights sum to 1, so 0.21 plus x plus 0.36 equals 1. Rearranging this gets you x equals 1 minus 0.21 minus 0.36. This results in x equals 0.43. This brings us to our next point. What do we do when there are two unknown variables in the weighted average equation? For example, if we only know the percentage of properties sold that must be apartments, but not townhouses and mansions. To do this, we'll use a similar approach and remember that all the decimal weights add up to 1. We have the equation x times 910,000 plus 0.1049 times 2,000 plus z times 6 million equals 2,630,353.8. Our first step would be to rewrite one unknown variable in terms of the other unknown variable. Keep in mind that x plus 0.1049 plus z equals 1. Let's manipulate this equation to write z as 1 minus 0.1049 minus x. Take note that all three weights add up to 1, not just one or two weights. It would be incorrect to write z equals 1 minus 0.1049 or z equals 1 minus x, for example. After rewriting the z variable, our equation is now x times 910,000 plus 0.1049 times 2,000 plus 1 minus 0.1049 minus x times 6 million equals 2,630,353.8. Now we can expand the equation and solve for x. Keep in mind the order of operations. We need to distribute the 1 minus 0.1049 minus x with the 6 million. The result is x times 910,000 plus 0.1049 times 2,000 plus 6 million minus 629,400 minus 6 million x equals 2,630,353.8. To solve this equation for x, we would first combine like terms by moving all the values with x to one side of the equation and constants to the other side. We get x times 910,000 minus x times 6 million equals 2,630,353.8 minus 0.1049 times 2,000 minus 6 million plus 629,400. We simplify both sides of the equation to get negative 5,090,000x equals negative 2,740,456. X equals 0.5384. Since z equals 1 minus 0.1049 minus x, z equals 1 minus 0.1049 minus 0.5384 equals 0.3567. We can check our answers by plugging the x and z values back into the given equation. We get our weighted average of $2,630,353.80. Let's try one more problem. X times 24 plus 0.23 times 50 plus y times 47 equals 32.671. Assume all weights add up to 1. The correct answer is C. To solve for x, we can rewrite the equation as x times 24 plus 0.23 times 50 plus 1 minus 0.23 minus x times 47 equals 32.671. Notice how we rewrote y as 1 minus 0.23 minus x, not 1 minus x or 1 minus 0.23. Again, it is important to remember that all the weights add up to 1. After solving for x, we can then solve for y by plugging x into y equals 1 minus 0.23 minus x equals 0.1170. Alternatively, if we want to solve for y directly, we can write x in terms of y as x equals 1 minus 0.23 minus y and then solve for x given y. Either way would give us the correct answer for both unknown variables. Thank you for watching this video. Next time, we will explore how weighted averages can be used to solve isotope problems.